Hi, everybody. So this is our video on unit analysis. This video is the last for chapter one, and we will go over a series of sample problems to help you guys get back into the swing of things for unit analysis. And I'm working on my iPad, so bear with me. This is already like my third take on this video, so hopefully I get the technology right. So what we will do is we will start with this problem. What is a liter? So a quart container of ice cream is to be made in the form of a cube. What should be the length of each edge in centimeters? And we're given the hint 1 gallon is 3.786 liters. And we're going to use unit analysis for all of this. So this quart could be a cylinder, it could be anything. We just know that we have a certain volume of ice cream, a quart of it. And we are going to form it into a cube and figure out what is the length in centimeters of this cube. Now, let's go ahead and move this to the Notes app. Okay. And that's recording. Good deal. All right, so we start with 1 quart, okay, over 1 times in a line. So first we have quart to a gallon. So if you don't know how many quarts are in a gallon, there are 4 quarts to 1 gallon. Okay, and then we are just given 1 gallon is 3.786 liters. 3.786 liters. Now, if you notice, the only reason we had to do this step right here is because we were given gallons to liters. If we were given quarts to liters, then we could have done that instead, right? But we have to go with what we're given. That's going to be the driving force of basically every problem you go through. You can't invent information. You got to go with what you're given. All right, next we have liters, and we want to get to centimeters. So we can take 1 liter to 1,000 milliliters. And if you don't know how milliliters get to centimeters, we can use a cubic centimeter. So 1 milliliter is 1 cubic centimeter. So we can, let's walk through this. We cancel out our quarts, cancel out gallons, cancel out liters, cancel out milliliters. And that will leave us with cubic centimeters. So let's do that math. Get out your handy dandy calculator. Okay, so you've got 1 divided by 4 times 3.786 times 1,000 times 1. Okay, so then we have 946.5 cubic centimeters. Okay. Now that's the volume of the sphere, not the sphere. This is a cube, right? Yes, of a cube. So now we have to think about, how do you get the volume of a cube? Well, the volume of a cube is the length of each side times itself 3 times. Or you could say that is the length cubed, right? So if we want the length, then we would take the cube root of the volume. So if we take the cube root of 946.5, then we get, I got 9.82. Okay, 9.82 centimeters. So that would be the length of each side of that cube. If we were going to take a quart of ice cream, cram it down, that is 9.82 centimeters, which is not a bad size cube. That's got pretty decent size to it. Okay, now let's jump back to the slides and let's go to the next problem. Now, some of these I'll have you guys do on your own, and some of these I'll actually work out. So, for example, if Mr. Pentecost claims to be 864,326,55 seconds old, how old is he in standard Earth years? So, let's go and figure this out in the notes. Okay, so let's draw a line there so I know not to go back up to that problem. All right, so we have 864,326,055 seconds. That is what we're given. Now, if we want to get that to years, what we'll do is we will baby step this all the way up to years by converting unit by unit by unit. Okay. You can always skip seconds, minutes, and minutes to hours because we can do 60 times 60 is 3,600. So you have 3,600 seconds to 1 hour. Then you have 24 hours in 1 day. Then you have 365 days to 1 year. So, if you get out your handy dandy calculator, you take 864,326,055, divide by 3,600, divide by 24, divide by 365. Oh no, and then hopefully you don't have a complex fraction. So let me fix my calculator real quick. Let's see. Oh no, I messed up. Okay, 1 second. All right, so I get 27.41. 7.41. Sorry for penmanship. Let me fix that real quick. $27.41 years. So the answer, it was asked how many standard Earth years. You would round that sucker to 27 years old. Bet you didn't know I was that old or young. So 27 years old. Now, if we go back to the slides, there is a bonus. So I will, I'll give you guys a bonus. The first person to put my birthday, the correct month, day, and year into the discussion board will get a stamp, and a stamp is worth 5 points. Since I can't stamp you virtually, then we will. I'll just give you 5 bonus points. So 5 bonus points for the first person that gets my birthday, using that right there, the seconds. Now, number 2, this is an exercise we use usually in class. Try to estimate in your head how many seconds old you are. And how you would do that is you would take your approximate age, multiply in your head by 365 and by 24 and by 3,600 to try and estimate your own age in seconds. If you can do that, that's great. If you can't, don't worry about it. not on the AP test. But that's a fun little exercise that we usually do. So give that a shot. Pause real quick and see if you can estimate your own age in seconds. All right, now, here we go. Now, number 3, if Mr. Pentecost has 4.94 million in the bank, what do you infer? So, the answer to this is that you infer that Mr. Pentecost is either a bank robber or filthy stinking rich. And the answer is neither. I am not filthy stinking rich nor a bank robber. But the reason that you should not infer that is because I didn't give you any units on that number. You don't know what I have in the bank. If you convert 4.9, you don't know if that's 4.94 pennies, 4.94 nickels, who knows? So you can't infer, you can't really do anything with numbers if they have no units, right? If there's no unit, you don't know what they're talking about. So I challenge you, don't put this in the discussion, but I challenge you to try and figure out what I do have in the bank, because I can guarantee you 4.94 million is not in dollars. All right, now the one that we will work with is number 4. Mr. Pentecost was born 6.022 times 10 to the 16th angstroms from this school. Okay. Now, first, how many miles away is that? So let's go to notes, squiggle, 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 squiggle. And first, let's figure out what an angstrom is. So if you don't know what an angstrom is, you should Google it. An angstrom is 100 millionth of a centimeter, or 10 to the negative 10th meters. So we will use that first. We have 6.022 times 10 to the darn. How many? 6.022 times 10 to the 16th angstroms. That's what we start with. Now then we use our conversion ratio, right? An angstrom, 1 angstrom is 10 to the negative 10th meters. Angstroms are commonly used with wavelength. It's something that I used in astrophysics when I was in college. So that's why we used a funny little unit there. Angstrom also usually has a halo or a circle at the top of the A. So to keep the unit symbol appropriate. Now we have to convert meters to miles. Now, how I would do this is I would convert meters to centimeters and then centimeters to inches, because that's the only conversion ratio I know off the top of my head. 2.54 centimeters is 1 inch. And we were not given anything else in the problem. So if you know how many meters are in a mile, great. I don't. So we are going to go all the way through meters to centimeters, centimeters to inches, then inches to feet and yards and miles and whatnot. Okay. So let's work our way through it. 1 meter is 100 centimeters. And then, nope, whoops, back. 2.54 centimeters is 1 inch. Then 12 inches to 1 foot. Then 5,280 feet to 1 mile. And then from that, and you can see my penmanship is starting really big and getting really small. I keep running out of room on this thing. I will get better. Now we will break these down. Angstroms, cancel. Meters, cancel. Centimeters, cancel. Inches, cancel. And feet, cancel. Leaving us with miles. So this number, if we take 6.022 times 10 to the 16th, and then we multiply that by 10 to the negative 10, then we multiply by 100, divide by 2.54, divide by 12, and divide by 5,280, you should get 3,742. 3,742 miles. Okay. Now, that's how many miles away from this school that I was born. Now, bring it back. There we go. So that's the answer to 4A, how many miles away I was born. Now, for B, in what city was I born? Usually I have you guys do this in class. You guys get 3 guesses, and then you guys can guess where I was born. But now it's a bonus. So go to the discussion, and the first person to correctly guess where I was born gets to stay. 5 bonus points. Ready,